Hello everyone, I will be talking about transformations of functions, vertical and horizontal shifts in this micro lecture. So the question is, how does the graph of a function change if it is altered by simple operations such as addition or multiplication? These changes are called transformations in general. So let's say we have a function. Now I do one simple operation to this function and ta-da! I get a new function. This function still keeps the main properties of the original function, but some things are changed. We will analyze what changes and how in this micro lecture. Let's compare the graphs of f of x equals 1 over 2x and g of x equals 1 over 2x plus 1. These are linear functions, so the graphs are just simple lines. We can create a table of values and obtain the graph of f. We can do the same for the second function and get the graph as another line. You can see the difference. For example, look at the first graph. It passes through the origin, but the second graph passes through the point x equals 0, y equals 1. So the y-intercept is 1. So the second graph is shifted 1 unit up. In general, let f represent a function and c a positive real number. Then the graph of y equals f of x plus c is the graph of y equals f of x shifted c units vertically upward. And the graph of y equals f of x minus c is the graph of y equals f of x shifted c units vertically downward. So we simply move the graph up if we add a number, or we move it down if we subtract a number. So let's consider another example and graph y equals square root of x minus 3. Realize that this is a transformation of the square root function whose graph is familiar to us. So we first graph y equals square root of x. If you hesitate how it looks like, you can always make a table of values and obtain a sketch of the function. Now we have the graph of the square root function. We can simply shift this 3 units down to obtain the graph of y equals square root of x minus 3. So the purple graph is the one that we were looking for. So far, we have only considered the changes to the graph when a number is added to the function or the y values. We will now consider the changes to the graph when a number is added to the x values instead. What do we mean by that? Remember the function notation. X is the input, or what we plug into the function, and y is the output, or what we get as a result. In the cases we considered, the operation was outside the function, and the changes were done to the y values. In the case we will consider now, the operation will be inside the function, and the changes will be done to the x values. Let's consider an example. Let's compare the graph of the x squared function with two similar functions g of x and h of x. The function f is simply the square function. Given an input number x, it squares it and gives an output number x squared. In both of the functions g and h, there is some squaring process going on together with addition of 2. However, what differs in these cases is the order of operations, and this changes whether the operation is done to x or y. In part A, given an input number x, it is first squared by the function g, and then number 2 is added. Before the addition of 2, we first get x squared, which is equal to the original function f of x. So 2 is added to f of x, which is a y value. So in part A, the operation is outside the function and the change is done to the y values. Therefore, the result on the graph will be a vertical shift. We are all familiar with the graph of x squared, which is a parabola. This is the graph of f. Now, to obtain the graph of g, we simply shift the graph of f 2 units up. We see both graphs on the right, where blue is the graph of g. So this answers part A. Now let's look at part B. We were talking about order of operations. Here we first add 2 to x and then square. We are doing the change directly to x values. To see how big of a difference this makes, let's expand this multiplication. As we all know, we get 3 terms, a trinomial, when it is squared. If we compare it with the original f function, there are two terms added to x squared, 4x plus 4. And this is not simply a constant number, so we cannot move the function up or down a constant amount. However, there is still an easy way to deal with this change. Since we changed the x values, we will move the graph on the x-axis. This is called a horizontal shift. How we do the horizontal shift may not be as intuitive as a vertical shift. To understand this, let's make a table of values for both functions f and h. We compute the function x squared for x values between -3 to 3 and obtain the y values. We do the same for the h function. Now, compare the y values in the two tables. The y values that are highlighted in red on the first table, 1, 0, 1, 4, 9, also appear in the same order on the right table. If we compare the x values corresponding to these y values, we see that the x values on the right are 2 less than the x values on the left. This tells us how we should change our graph. We should decrease the x-coordinates by 2 to obtain the points on the new graph. In other words, we should shift the graph of f 2 units to the left. Here we plot both graphs on the same coordinate axis. The red one is the graph of the original function x squared obtained from the left table of values. And the green one is the graph of x plus 2 squared obtained from the right table. We see that the green graph is the same as the red graph, just shifted 2 units to the left. In general, let f represent a function and c a positive real number. Then the graph of y equals f of x plus c, which is shown in orange, is the graph of y equals f of x, shown in green, shifted c units to the left. And the graph of y equals f of x minus c, shown in red on the right, is the graph of y equals f of x, shifted c units to the right. We simply move the graph left or right when we add a number to or subtract from x inside the function. Let's look at another example. Let's graph the function f of x equals absolute value of x minus 3 using transformations. So this is a transformation of the absolute value function. Therefore, we first graph the function y equals absolute value of x. Next, we shift the graph 3 units to the right, since 3 is subtracted from x inside the absolute value. Congratulations! Now you have watched the vertical and horizontal shifts lecture. You can go ahead and complete your assignment on this topic.